Hi guys, here we go with another video. This one we're going to take the information you learned in ESS 2.6 and now we're going to use that knowledge you have about how air masses and weather fronts create weather, and we're going to add in the tools that meteorologists use to predict weather, and hopefully by the end of this you'll be able to look at data charts and look at what information they give you and predict what the weather's going to be. So let's look at our first tool, and that's going to be a thermometer because we need to look at air temperature. Of course, the thermometer tells us how much heat is present. So how hot or cold is it outside? Our units that we're going to use for temperature are Fahrenheit or Celsius. Make sure that you know whether the question you're looking at asks you if it's Fahrenheit or Celsius. And that will make a big difference because 30 degrees Celsius is around 90 degrees Fahrenheit. Big, big, big difference. 32 degrees Fahrenheit is freezing. That's our fabulous snow temperature. But that would be 0 degrees Celsius. So make sure you're looking at what unit air temperature is being measured in, because that can make or break your answer for a question. The next thing that we're going to look at is air pressure. This is huge. We have to know the air pressure. And we talked about high pressure being happy weather and low pressure being lousy weather. And the tool that we use to measure air pressure is called a barometer. Barometers are typically given to us in inches of mercury. We don't really need to get into why that is or what that is. Save your brain space for some other stuff right now. Unless you've got this and you want to dig deeper, then by all means go check out inches of mercury. But remember, high pressure is clear skies, good weather. Doesn't mean it's going to be hot outside. Doesn't mean it's going to be cold outside. Just know high pressure is happy weather. Low pressure is lousy weather. This is where we're going to have clouds and rain. When you look at a barometer, there are happy little pictures on there to help us out. So if you'll notice on this image of a barometer, there's a cloud with rain, there's a sunshine, there's just a little cloud with a little sun hiding behind it. So it tells us that high pressure, we've got clear skies, the sun, and low pressure, we have clouds and possibly rain. There's a closer image of that barometer. So look at those pictures on the barometer, and that gives you an indication. So if we're over here, we're going to have rain in the lower numbers. If we move over here, we're going to have high pressure. Now be careful, because in some questions, you're going to see all these different numbers for air pressure, and I do not expect you to know what those numbers are, like what number equals high pressure, what number equals low pressure. What I want you to do, and we'll go over this when we look at a data chart, is to look, are the numbers going up? So do we have increasing pressure, which means it would be clearing, or are our numbers going down, which means our air pressure is decreasing and we're heading to cloudy, possibly rain or snow. The next instrument we're going to look at is a funny name, and it's a funny looking instrument. It's called a sling psychrometer, and this measures humidity. That's how much water vapor is in the air, and we get this in percentages. So when you are out in the summer and it feels almost like you're walking through water, the air is heavy, it's got tons of moisture in it, that's a high humidity. Sometimes we get into like 80-90% humidity. If you've got 100% humidity, you have precipitation. If it's really dry, especially on these cold winter days where there are no clouds, we have really dry air. That means we don't have much moisture in the air, and that is our humidity. So we watch for humidity. If the humidity is going up, we have a better chance of precipitation. If the humidity is way down, we have less of a chance of precipitation. The next thing we're going to measure is wind, and we measure this with something called an anemometer. An anemometer tells us wind speed, and we get that in miles per hour. Direction is going to be found by a weather vane or windsock. But an anemometer spins around, and we have a few on hand, so ask if you'd like to look at an anemometer. And the wind blows through a little wheel, and that spinning wheel will tell us how hard, how fast that wind is blowing. Dew point is measured with a hygrometer and a thermometer, and this tells us that, like, what temperature Is the air completely saturated with water? And we're going to get this in degrees of Fahrenheit. So if we have a really high dew point, then it's going to have to hit that higher temperature for the air to be completely saturated. If we have a very low dew point, then we have a lower threshold for the air to become saturated. Doppler radar, one of my favorite things to look at on the news. If I'm watching to see what weather systems are coming through, I look for the Doppler radar. And not only is it pretty, but it tells us a lot of different things. They use this really cool satellite that swoops around in 360 degrees and gives us this like ever updating image of what's happening. If you want to look into Doppler and the Doppler effect, it's really cool, but save that only if you're in your priority 3 questions. The cool thing about Doppler radar is it tells us not only what kind of precipitation we're getting, but it tells us how heavy the precipitation is. And we can actually see the movement as it's coming down. The jet stream is not a tool. The jet stream is just something I want you to keep in the back of your mind. These are narrow belts of high-speed wind, and they're up miles up in the air, and they don't really have a regular pattern, but these are just like really strong belts of wind, and they can go like, I believe, 200 to 400 miles an hour. So jet streams have big impacts on our weather, but we're not going to study them in depth. It's just something to know about and kind of keep in the back of your head. So let's look at this cool chart. It tells us air pressure, and then it gives us like evidence and prediction. So it kind of gives us something to look at. So the text clue is air pressure. If the air pressure is increasing, we get fair weather. That just means it's going to be nice and clear. If the air pressure decreases, we get clouds and rain. And then it also tells us here about cold fronts, warm fronts, stationary fronts, occluded fronts. You don't have to know clouds, but if your brain's already on top of all this stuff and you want to add a little bit more, check out the stratus, cumulonimbus, cirrus, and cumulus clouds. Temperature. If it's above 32 degrees, and that is Fahrenheit, that means we have rain as precipitation. If our temperature is below 32 degrees Fahrenheit, that's when we get snow, sleet, and freezing rain if there's precipitation. Humidity. If the humidity is increasing, this means we're going to get more clouds and a better chance of rain or snow. If our humidity is decreasing, we get less chance of cloud development and a less chance of precipitation. I will have this weather chart for you, so make sure you look for it in the Canvas module. Alright, let's look at 4 prediction questions and work through how we do this. So question number 1. In 5th period, the temperature was -1 degree Celsius, the barometric pressure was 28 and dropping, the humidity was 75% and rising. So what would be our prediction for 10 o'clock that evening? A, hot and clear. Can totally rule that one out because -1 degree Celsius is extremely cold and below freezing. B, snowy and cold. Now, this is a really good possibility because I have dropping air pressure and rising humidity plus colder temperatures. So I'm going to hang on to B. Let's look at C, rainy and warm. Well, it's definitely not going to be rainy because of the temperatures. If there's precipitation, it's going to be snow. And warm is ruled out by the -1 degree Celsius. And D, cold and clear. Well, it will be cold, but if I have rising humidity and dropping air pressure, it's definitely going to be like cloudy with precipitation. So my best answer for this question is B. So I would say B, snowy and cold, is my best prediction for 10 o'clock that evening. Let's look at number 2. At 10 o'clock, the barometric pressure is 29.02 and slowly decreasing. The temperature is at 14 degrees Celsius and dropping, and the humidity is at 79%. Also, an occluded front is to the west with winds blowing at 15 miles per hour. What type of weather would you predict for the remainder of the day? Now, let's use our data. I know that if the air pressure is decreasing, This means we're going to get clouds and some precipitation. My temperature is at 14 degrees Celsius. If this were Fahrenheit, I would be below freezing, but it's not. This is Celsius, and 14 degrees Celsius is above the freezing mark. Even though my temperatures are dropping, I have humidity at almost 80%, and I know an occluded front is coming at 15 miles an hour. So for the rest of this day, I would expect it to be very cloudy. I would predict that we're probably going to have some kind of thunderstorm or severe rain. And if the temperature drops enough and fast enough, we might end up with snow. But I could definitely bet on severe storm, cooler temperatures, and just a cloudy, nasty kind of afternoon. Let's look at number 3. At 12 o'clock, the barometric pressure is 30.78. The temperature is 20 degrees Celsius, and the wind is 2 miles per hour northwest-north. The humidity is at 51%. What weather would you predict for 5 p.m.? So we have a high barometric pressure. We have a really nice temperature, so 20 degrees Celsius is really nice and warm. And our wind is really low, so we may have like a slight breeze, but not much at all. And 51% humidity is like perfect. We're talking like the perfect day. So let's look at our choices. A, cold and rainy? No way. We have high pressure and warm temperatures. B, warm and dry? Absolutely a possibility. C, warm and cloudy? Well, we've got the warm, but we don't have the cloudy because we have really high pressure. And D, warm and rainy. Again, we have the warm, but we have too high pressure for rain. So I'm choosing B, warm and dry. All right, let's look at our last question, number 4. On a winter evening, this is key, winter, the pressure is 30.76. So we have high pressure, and that pressure is steadily decreasing. The temperature is decreasing pretty quickly. They are predicting a stationary front. The relative humidity is 60%. The jet stream is dipping to near to our area. What weather would you predict for the next morning? So based on all of this, I have dropping air pressure, I have dropping temperatures, and I have a stationary front that's going to bring in days of rain. This isn't a quick moving thing. Humidity is pretty high. So I would predict that we're going to have it's going to get cooler and cooler and probably really windy. We're going to have clouds moving in. And the next morning we're either going to have rain or snow, and it's going to be kind of yucky and nasty for the next few days. Those are my weather predictions based on this data. Remember, there's going to be practice that you can do. Ask your teacher questions. Make sure you take good notes, and good luck on this next standard, ESS 2.5.